Good morning students, welcome to the online class DO Nalgonda. Today we are here to learn about the acids, bases and salts. In earlier classes we learn about the acids, bases. Acids are sour to taste, they turns blue litmus paper to red. Bases are soapy to touch, they turns red litmus paper to blue. So here there are the indicators, the substances are to test the acids and bases. So there are three types of indicators is there: natural indicators, synthetic indicators and olfactory indicators. In natural indicators, litmus paper, turmeric, beetroot, some colored petals of flowers. So by using this natural indicators, we can identify the acid substances and basic substances. Okay, if suppose litmus paper, there are two types: blue litmus paper, red litmus paper. By using that litmus papers, we can identify the acids, bases. Turmeric powder, we have to make it a paste, the turmeric powder. Then that paste you have to apply onto the paper, we can get turmeric paper. The turmeric paper on, you add acid or base. So we can change the color. By changing the color, we can observe the acids and bases. So there are the another indicators, synthetic indicators. They are phenolphthalein and methyl orange indicators. In the phenolphthalein indicator, by using phenolphthalein indicator, in the acid substances, the phenolphthalein indicators are, it shows its colorless, it is colorless, and in the bases it shows the color is pink color. In the methyl orange indicator, by using methyl orange indicator, acids are, it shows the red color. In methyl orange indicator, the basic substances are, shows the yellow in color. So this like natural indicators and synthetic indicators, by changing the color we can observe the acid substances and basic substances. Here few examples is there: hydrochloric acid, sulfuric acid, acetic acid. The formulas HCl, H2SO4, CH3COOH, and the bases are sodium hydroxide, magnesium hydroxide, potassium hydroxide. So these substances we can identify by using the indicators. So these three substances, HCl, H2SO4, acetic acid, turns blue litmus paper to red. In the phenolphthalein, these substances are, it's colorless, and in the methyl orange, these substances, it shows the red in color. And the substances are sodium hydroxide, magnesium hydroxide and KOH. These substances are, red litmus paper change into blue, and phenolphthalein is change into pink color, and methyl orange drops is added to these substances, it change into yellow in color. So these are the natural indicators and synthetic indicators. Another one more indicators is there, they are olfactory indicators. Okay, olfactory indicators means there are the substances whose order changes by adding acids and bases. Here the natural indicators and synthetic indicators are, by changing the color we can observe the acids and basic substances. But in the case of olfactory indicators, by changing the smell, okay, by changing the smell we can identify the acids and bases. Okay, for example, onion and clove oil and vanilla essence. Okay, so these substances are, we can use it as a olfactory indicators. How they are means, for example, onion. If you take onion, cut into pieces, then make it to paste. That paste you have to hold it into the one cotton cloth. Then in that paste you have to keep a paper strips. Okay, that paper strips you have to place into the paste, and the total you have to hold it into the cotton cloth. Then cotton cloth, the total paste with cotton cloth is, you have to keep it in a refrigerator overnight. So then next day you take out that cotton cloth which contains onion paste, contains paper strips. So next what do you get? That paper strips is has a onion smell. That onion smell of paper strips on the, you place one onion strip on, you place acid, in another onion strip you place the base. So acid, if you place acid on the onion strip, it gives one, the smell is changed. If you place the base in the onion strip, it gives another smell. So this like, we know the onion smell, but the adding of acid and base, the smell is changed. So that like same, vanilla essence also. For example, 2 test tube you take, one test tube contain acid and one test tube you contain base. In the acid contained test tube, we add vanilla essence, and a basic test tube contain add vanilla essence. In this two test tube, acid containing vanilla essence gives one different smell, and basic containing vanilla essence gives different smell. So thus like we can, these all are having a characteristic smell. That characteristic smell is changed by adding acids and bases. So this is the olfactory indicators. So in this acids and bases we identified by using these three types of indicators. Okay, what they are? One is natural indicators, and one is synthetic indicators, and one is olfactory indicators. Okay, in the natural indicators, so there are the substances naturally we occurred. Okay, beetroot paper is also we have to prepare same turmeric paper. Okay, some colored petals of flowers also we can prepare same turmeric paper. So adding acids and bases, these two changes the color. Here is also phenolphthalein and methyl oranges changes the color. These two indicators are, by changing the color we can identify the acids and bases. In these olfactory indicators, by changing the smell we can identify the acids and bases. Okay, so this is about the identify of the acids and bases by using the indicators. Okay, next next we go for reactions of acids and bases with acids and bases reactions. So there is the one reactions of acid and bases with the metals. Okay, reaction of acid and bases with the metals. Okay, so how the chemical reactions of the acids and bases with other substances. Here one is there, acids and bases, how they are reacted with the metal. So first let me take metal and the react with acid. The reaction between the metal and acid, it gives salt and it releases the hydrogen gas. Okay, so let me take one metal, for example zinc metal. The zinc metal is reacts with hydrochloric acid. It gives, here you see here it is the zinc metal, it is the hydrogen and it is the chlorine. So the zinc is more reactive than hydrogen, so it is easily replaced. This zinc is easily replaced in the place of hydrogen, so it forms the zinc chloride, and the hydrogen is separated, it forms hydrogen gas. Okay, so this reaction, okay, this reaction we can observe in the textbook. Okay, you have to take one test tube. In this test tube you have to place zinc metal. Okay, then add dilute HCl. Okay, then add dilute HCl. Okay, so next you keep one whole rubber cork. Okay, once place the dilute HCl, immediately you keep one whole rubber cork. Okay, in this one hole you have to keep one migrating tube. This migrating tube you have to, here you take one beaker which contains the soap water. Okay, which contains the soap water. This is the soap water. Okay, so this like operators you have to arrange it to react the zinc metal and dilute HCl. So what are the observations we can observe? What are the reactions is occurred in between the zinc metal and dilute HCl? What is occurred in this reaction? So first here you keep one and stand. Okay, so here it is the test tube. Okay, it is one whole rubber cork. It is the migrating tube. Okay, So here the zinc metal first you placed in the test tube, then add dilute HCl. Okay, immediately you have to fix the one hole rubber card. Okay, through this one hole you have to keep migrating tube. One end you have to place in the test tube and another end you have to place into the soap water. Okay, so the reaction start between the zinc metal and dilute HCl. So what is happened? Zinc and HCl they react together. It gives the zinc chloride and release the hydrogen gas. So which is released, we have to keep upward arrow. So that hydrogen gas is released through this migrating tube. It is passed through into the soap water. So any gas is passed into the soap water, it gives the bubbles. Okay, what is gives the? It gives bubbles. So this bubbles to test this bubbles, we have to keep one burning candle. Okay. Okay, we have to keep one burning candle at the near of this bubble. So what is happened? Generally hydrogen, you see hydrogen is the combustible gas. Hydrogen is the combustible gas but do not supposed to combustion. But do not supposed to combustion. Okay, so what is happened in the reaction? The bubble near, you bring the burning kernel near to the bubble. What is happened? The bubble gas filled with the hydrogen gas, it is burns itself. The candle is put off with the pop sound. So that is observed in this reaction. So why? Because the hydrogen gas is the combustible gas but it do not supposed to combustion. The burning candle is burning but the hydrogen gas is put off the burning candle but hydrogen gas burns itself. That's why the bubble containing hydrogen is burns, the burning candle is put off. So that what we observed means the hydrogen gas is burns and with the pop sound. So the candle is put off. This is observed in this reaction. So in this reaction what is the gas is released means the hydrogen gas is released. So same like not only acids, any other acid also like H2SO4, acid HCl, not only HCl, any other acid also same we can reacts with metal, not only zinc, another metal iron. So that metals also it reacts with acid, it gives that corresponding salt and release the hydrogen gas. So it is the metal reacts with acid and release the salt and hydrogen gas. Okay. Similarly bases also same, they reacts with the metal and it also gives the corresponding salt and hydrogen gas. Okay. So for example you take NaOH and reacts with zinc metal, it gives sodium zincate Na2ZnO2 and release the hydrogen gas. Okay. Acids and bases too are reacts with metal, they reacts with the salt and hydrogen gas. So it is the one of the reaction of acids and bases with the metal. Okay. And next reaction of acids with the carbonates or bicarbonates. Okay, reaction of acids with carbonates or bicarbonates. Okay. For example, if you take hydrochloric acid, it reacts with the sodium carbonate Na2CO3. Okay. What are the products it produced? This acids reacts with carbonates Na2CO3, sodium carbonate. So it gives the sodium chloride and release the carbon dioxide gas and also it release the water. This carbon dioxide is the gas. Okay. So here the acid reacts with metal carbonates and it gives the salt sodium chloride and release the carbon dioxide gas and water. Okay. So this also we can observe in the okay, take two test tubes. In this test tube you add HCl, dilute HCl and sodium carbonate Na2CO3. Okay. Here is also equipped one hole rubber cork. This one hole rubber cork, another end you have to dip into the, this is contains lime water. Okay, what is this is calcium hydroxide. Okay. Okay, what is happen in this reactions means acid reacts with carbonates. Okay, dilute HCl reacts with sodium carbonate. So the reaction between the HCl and Na2CO3, the sodium chloride salt is formed, sodium chloride solution is formed and carbon dioxide gas is released. That carbon dioxide gas is passed through the migrating tube and enter into the lime water. Okay, what is happened when it is enter into the carbon dioxide is enter into the lime water. So the calcium hydroxide reacts with the carbon dioxide, it gives calcium carbonate and forms water. Okay. The calcium carbonate is downward arrow, it indicates it is formed the precipitate. Okay, white color precipitate is formed. Okay, so here you see the reaction of acids with the carbonates or bicarbonates. Okay, hydrochloric acid reacts with sodium carbonate, it gives sodium chloride, carbon dioxide and water. So that carbon dioxide, the passing of carbon dioxide gas, if it is passed through the lime water, okay, it turns into white precipitate. So the milk white precipitate is formation by calcium carbonate. Okay, the calcium hydroxide reacts with carbon dioxide, it gives calcium carbonate and release the water. So in this diagram we have to observe the test tube which contains the reactants, they are hydrochloric acid, sodium carbonate, the two are reacts together, it releases the carbon dioxide gas. This carbon dioxide gas is passed through the migrating tube and it is entering into the lime water. This lime water is calcium hydroxide. On passing carbon dioxide, this lime water is turns white color precipitate. Okay, this white PPT is by formation of calcium carbonate. Okay, if you pass excess carbon dioxide, if you pass, this white precipitate is further it dissolved. Okay, why? Because the calcium carbonate is further dissolved by passing of excess carbon dioxide gas. Okay, so this like not only carbonates, in the bicarbonates also. Okay, in bicarbonates also the acids are reacts with bicarbonates, it gives the same salt, carbon dioxide gas and water. Okay, not only sodium carbonates, any metallic carbonates or any metallic carbonates are reacts with the acids, not only HCl, it is maybe H2SO4 or HNO3, any acids they react with carbonates and bicarbonates, carbonates or bicarbonates, it forms the corresponding salt and carbon is carbon dioxide and water. So which is common here? Carbon dioxide and water is common by taking any carbonates or bicarbonates. Okay, so this is these are the reactions. Acids reacts with okay, what are the acids reacts with acids and bases reacts with metal, it gives hydrogen gas. Acids reacts with metal, acids reacts with carbonates and bicarbonates, it gives the carbon dioxide gas. Okay, these are the reactions of and next neutralization reaction. Okay, what is neutralization reaction means? For example, take one test tube. Okay, in this test tube you take 2 ml of sodium hydroxide. Okay, in this test tube you take 2 ml of sodium hydroxide What happen? Next you add drop by drop 2 drops of phenolphthalein. Okay, next in one test tube you take 2 ml of sodium hydroxide NaOH, you add 2 drops of phenolphthalein. Okay, what is happened here? It is NaOH is basic nature, to the base phenolphthalein is added. What is happened? The pink color solution is formed. Okay. Okay. 2 ml of NaOH, if you add phenolphthalein, what is get? Pink color solution is we can get. So, to this pink color solution, if you add dilute HCl, okay, if you add what? Dilute HCl, what is happen? The solution is slowly changed into colorless. Okay, the solution is slowly changed into colorless. Why? What happened? Here first base substance is there, you add phenolphthalein, so the basic on the phenolphthalein shows the nature is pink color and it shows the effect, the basic nature effect on the phenolphthalein, it shows the pink color solution. Next you add slowly drop by drop dilute HCl means the total NaOH is reacted with HCl. So you adding HCl means how much NaOH is 2 ml NaOH, how much 2 ml of NaOH, how much it reacts with HCl, it is reacted. The remaining what is left, HCl is left. That HCl with the phenolphthalein, what happened? It's colorless. Okay. So the nullifying the basic nature by adding HCl. Okay. Next, now you further add NaOH to this colorless solution. What happened? Again pink color is reappeared. Okay, again pink color is reappeared. Okay, so this like the reaction of base and acid, it gives okay, how much base is reacts with acid, it gives the two natures are nullified. Okay, basic nature and acidic nature is nullified. So basic nature and acidic nature is nullified means what we get? Neutral substances. Okay, so the base is reacts with acid, the nullified substance is formed. So that is the salt and water. So okay, generally dilute HCl antunnam kabatti, dilute HCl is contained water. So we can get base reacts with acid, it gives salt and water. So this like basic substances are reacts with acid, they produce the salt and water. So this salt has neither acidic nature nor basic nature. Okay, so it is a neutral. So this reaction is considered as a neutralization reaction. So neutral form avutunnayi kabatti, neutral size formed. So that's why it is a neutralization reaction. Okay, so the basic substances and acidic substances reacts together, it gives a neutral and water. These reactions are neutralization reaction. Okay. Not only NaOH and HCl, any base substance you take and any acidic substance you take, the two reacts together, that corresponding salt and water is produced. That reaction is considered as a neutralization reaction. Okay. So thank you children. Once I recall what are the topics is completed in this section. First, acids and bases are identified by using the indicators, natural indicators, synthetic indicators, olfactory indicators. Natural indicators means litmus, turmeric paper, beetroot, some colored petals of flowers, so we have to paste that affected on the acids and bases. Next is synthetic indicators, phenolphthalein and methyl orange. Okay, phenolphthalein how they are reacted and methyl orange is how they are reacted. Okay, next one is olfactory indicators. Olfactory indicators are the indicators the changing the color. The olfactory indicators are the substances whose order changes by adding acids and bases. Okay, example onion, clove oil and vanilla essence, how they are changing the smell by adding acids and bases. Okay, next the reactions of acids and bases with metals and the reaction of acids and bases with carbonates and bicarbonates. Okay, the reaction of acids and bases with metals hydrogen gas ni release chestayi, and the reaction of acids and bases gives the reaction of acids with carbonates and bicarbonates gives the carbon dioxide gas. Okay, next one, it is the neutralization reaction is important. The neutralization reaction means base is completely reacted with acid, it gives a salt and water. The two natures are nullified by producing of neutral. So, this is the neutralization reaction. Okay, thank you students, we will meet in next class.